So today we're continuing with our trig identities. Okay, so one of the things that I keep telling my students is that there should always be two things that you should have on your table or in front of you while you're doing these trig identities. One is the formula chart or some kind of formula chart, and the second one are these steps that I've given them. Okay. Matter of fact, in the notes it says to print this slide so that you can have it. So these are the steps that I use and I give them every single time. And we go through these every single time we do one of these identities. Okay? So we're looking here. So the first step is to look at the more complicated side. That's what we're starting with. And obviously the left side, definitely more complicated. So we're going to get this left side equal to this. This is the answer. Okay? What we're doing is we're figuring out how did we get to that answer. Okay? I already know what the answer is. I'm giving you the answer. So how do we get there? So let's start with the left side. Well, step one is to work with the more complicated side. Step two is to do any kind of algebra, any kind of foiling or factoring that's kind of obvious to us. And when we look at this, the first thing that jumps out at us is that we have sine and we have these parentheses with the trig functions in it. So there's some easy algebra that we can do. So the first step on this one would be to distribute in sine. So we end up with sine x cosecant x plus sine times sine is sine squared x secant squared x. Okay, so that's the first step, foiled it in. Now, cosecant times sine, this right here, sine and cosecant are reciprocals of each other. And when you take anything and multiply it by a reciprocal, you get 1. So that's 1 plus sine squared x secant x. Now, that 1 plus sine squared looks like the Pythagorean identity, but it's not. So we got to kind of switch one of these. But since my answer has secant squared in it, I don't want to move or change sine squared. So if I'm going to change anything, I want to change sine squared, not secant squared, because this is in my answer. So the only thing we really have for sine squared is our Pythagorean identity. So I'm going to change sine squared to 1 minus cosine squared, secant squared. Next, we're going to do what we did initially, and again, we're going to distribute in secant squared. So we get 1, I don't know why I put a plus there, 1 plus secant squared minus, and just like sine times cosecant is 1, secant and cosine are reciprocals, so when I multiply secant times cosine, I get 1. And then I have 1 minus 1, which means this is 0, which leaves me with secant squared x. So that's one way of doing it. Okay? Now, another way of doing it is, again, we're going to start off the same way where you distribute the sine in, but where the next one breaks is right here. Instead of changing sine squared to 1 minus cosine squared, on my identity sheet, I have at the top that tangent x is equal to sine x times secant x. And that's something that I did at the beginning in our notes, talked about how you rearrange identities. And since dividing tangent sine over cosine and dividing by cosine is the same thing as multiplying by its reciprocal, I have written down tangent equals sine times secant. So right here, when I take sine times secant, that turns it into tangent squared x. So this becomes this. And now I have 1 plus tangent squared, and in our steps it says when you see 1 plus a trig function or 1 minus a trig function like that, you look at the Pythagorean identities, and the Pythagorean identity for tangent and secant tells me 1 plus tangent is secant squared x. So that one saves us a little time and effort. Okay. Or you could have done the same thing, because you could have said that secant squared, multiplying by secant squared is the same thing dividing by cosine, and you would have gotten sine over cosine to do it that way. That would definitely have been a way of doing it. Or, again, this same step, I could have force factored out a secant. So in this step, if I factor out a secant, I would have gotten 1 over secant squared plus sine squared, like that. And 1 over secant is cosine. So this is cosine squared plus sine squared. And that's also a Pythagorean identity, and that is equal to 1. We still get secant squared x times 1, which is secant squared. So there's a bunch of different ways of doing this problem. Okay? Again, as long as you show all your steps, it doesn't matter which way you do it. Okay? Now, the second problem. Now, with the second problem, we're looking at it. Two things stand out right away. Okay, if you look at your steps that I've given you, again, start with the more complex side. Number 1. Number 2, look for algebraic simplifications. Doing multiplying, factoring, squaring. But the second bullet says reduce 2 terms to 1. Either add 2 terms, factor, or get common denominators so that you may reduce. And in my problem, I have 2 fractions. Also, this point says if you have denominators of 1 plus trig function, multiply the top and the bottom by the conjugate and use the Pythagorean identity. So this second problem uses both of those ideas, because in this problem I have, not only do I have 2 fractions here and here, this one and this one, that I got to get down to 1 term, I also notice that the bottom, they are conjugates of each other. So this is telling me exactly where I need to go. Okay? So what I'm going to do is I'm going to get common denominators. So, and this is where my students kind of get tripped up, because they think we're doing something different than we've done before. So I always refer them back to something like this. If I said add 1/2 and 1/3, which I know they can do, they would tell me, well, you got to get common denominators first. And I'd ask them, well, what's your common denominator? And they'd say, it's 6. I say, okay, well, how did you get that common denominator? And it's by multiplying the 2 denominators. It's the same thing here. What is the common denominator? The common denominator is the multiplication of the 2 denominators. This is the common denominator. And just like doing this one, you'd have to multiply this one, the top and the bottom, by 3, and the top and the bottom of this one by 2, the opposite's denominator. Over here, the same thing. The first one, I'm going to multiply the top and the bottom by 1 minus sine x. And this one, I'm going to multiply it by 1 plus sine x. So for this one, I get 1 minus sine x on top plus 1 plus sine x over the same denominator. Sorry, it should be minus. So when I do common denominators, I get their conjugates. And again, when you have conjugates like a plus b and a minus b, when you multiply them, that's your difference of 2 squares. So when I multiply 1 plus sine times 1 minus sine, I get 1 minus sine squared x. That's my bottom. Now I add the top. So I have 1 plus sine x plus, sorry, I keep doing that. 1 minus sine x plus 1 plus sine x on the top. Just like we do here, we end up with 3 over 6 plus 2 over 6, which ends up being 5 over 6. So when we get common denominators, we just add the numerator. So that's the same thing we did right here. Now, when I add them, I got 1 minus sine plus sine. That ends up being 0. So I end up with 1 plus 1. So I end up with 2 over 1 minus sine squared x. And as soon as I see that 1 and I see that squared trig function, I automatically look to my Pythagorean identities. And under my Pythagorean identities, I have written down that 1 minus sine squared is, in fact, cosine squared. And again, using that idea of dividing by something is the same thing as multiplying by its reciprocal, which means instead of taking 2 and dividing it by cosine, I'm going to multiply by its reciprocal, which is secant, and then that is my answer. And now my left side equals my right side. Now, there are other ways of doing this problem without doing the conjugates, but they're definitely much more difficult. This is the fastest and most straightforward way. This is the way I would suggest doing it. But the most important thing is that, again, why do some of my students see this process right here different than this process right here? And the only thing they can tell me is it's got more letters. But it's the same, mathematically it's the same process. Visually, it does look more complicated. But don't let your eyes fool you.